Hi, welcome back. Next up, we're going to talk about the web frameworks that make up Galaxy, um, and the interaction between Galaxy and the web server. And call it the architecture of an interaction. So, at a very high level, what happens when you visit Galaxy? Your web browser makes a page request to a web server somewhere running Galaxy via HTTP. And some static content is returned: HTML, JavaScript, CSS content, and then components that make up the Galaxy front end, mostly built using Vue.js, um, run and activate and start working. Axios is used by the client layer to build service layers, which make API requests um, back to the server. The server builds the JSON response in Galaxy API controllers. That API response comes back as JSON. These JSON objects are stored in Vuex stores or consumed by components directly. And then HTML is rendered from Vue.js component templates based on that data. So this is the high level overview of what happens in a sort of in the ideal case. There are bits and pieces of older client technology like scattered throughout Galaxy, ranging from Python Mako templates that generate HTML. So you're getting HTML sort of back from the server here, or low-level jQuery and lots of backbone legacy MVC stuff that is making API requests instead. But the amount of this legacy code is decreasing, and with this sort of central dogma of the interaction between Galaxy client and server is becoming more and more um, a complete picture. So we can sort of expand the right side of that diagram and move through these components left to right. Um, so in the last, let's say, half year or maybe even a last year, there's been a huge shift on the back end, and we are sort of moving towards Fast API and ASGI from WSGI. So we'll talk a lot about that, but just know that this picture isn't is sort of like what the default will be, probably starting in 2109, and certainly you can run Galaxy this way now. But there's the older way is the picture looks a little different, but similar layers exist. But as we expand the backend piece here, we've got an ASGI server. It sort of takes a TCP request and builds some ASGI arguments from it. Talk a little bit what that means. And then Fast API is a layer that is an application, basically an ASGI application. It's built on Starlet. It uses some middleware. It's got a router. And that router sort of gets you to the right piece of Galaxy code, and then gives Galaxy pedantic models. So the between the router and the controller, we sort of enter from what I would consider like framework code we don't really run in Galaxy. We set it up, but we didn't write it, to Galaxy backend code that we really do write. And so for these newer controllers, for newer Fast API server, we're given pedantic models, which we turn into Python objects. Sometimes we keep the pedantic model, sometimes we do other things. And then we just make vanilla function calls from the controller to the manager and other components below. But basically, this is the business logic of the Galaxy backend. Yeah. And so these managers produce Python objects, give them back to the controllers. These controllers, we'll talk a lot more about them, lightweight little things that don't try not to do business logic, but just sort of prepare requests and return response objects. In this case, again, pedantic models both ways. All of this here is sort of represented as like a linear chain of calls, but in the async world, it's actually firing off events and stuff. So this diagram made a lot more sense under WSGI, but it's what we have for now. Yeah, so what is this ASGI thing? So it's the spiritual successor to WSGI. It's like an async version of that spec. But what is WSGI? Well, we'll talk a little bit about that later on, but it's basically just a Python interface, essentially, that defines an application. This interface, and it's an interface in like the highest level sense. It's just like a way, like a method declaration essentially, or a template for how methods should respond. It's an asynchronous Python 3 function. Um, you know, it can be called whatever. Here the example is called application. It takes in a scope, which is a dictionary describing the connection, receive an async callable to like respond to messages, and then send an async callable to send messages. And so, yeah, you wait for messages, you respond to them, and that's the application. The ASGI documentation has more details. Probably you don't need to read through it and understand the specification to program Galaxy. I say probably, but I mean certainly not. But this is the architecture talk, so I'm giving you the link. To sort of build up our ASGI application, we use Fast API, which extends Starlet. So I'm going to talk a little bit about Starlet and the low-level example, just to sort of understand what I mean when I'm describing that application, and just to see some sort of simple examples. But yeah, and when we do this, because a lot of the plumbing in Fast API is really just Starlet. So here's like the simplest Starlet example from their web page. You've got that async app scope receive and send. You've got that same function declaration there, and we're importing plain text responses. So we're going to sort of assume we've got an assertion here that all of our scope is HTTP. We're going to build a response for any request, and then we're going to respond with that. So if we hit this server, at any sort of location underneath this server with any sort of request arguments or post body arguments, whatever, we're always going to get hello world. There's no routing happening here. But this is a simple application that is an ASGI application. So we can place in a file called example.py, .py. And as long as Starlet is on the Python path, and we've got UVcorn, which is the ASGI server, an example ASGI server that we could use, we can sort of say UVcorn run, the code in example.py, and the application we actually want to run is called app. Right here, you can see that, and it's running, and then we'll get that hello world. And so this is a simple example from the Starlet webpage. A sort of slightly higher level example that shows some routing is this. Rather than define our own app, we're going to sort of use the Starlet application. We're going to sort of use JSON responses, and we're going to create a route. So our application, just has one route. It's the root route, and it runs homepage here. And what does homepage do? It takes the request, and it returns, hello world as a JSON. So it's a different application. It's only going to respond on root, but it demonstrates, how to use the Starlet application in some simple routing. And so Fast API just sort of extends this with some more goodies, let's say. So if we look at Fast API applications, we can sort of see it imports the Starlet application and sort of extends it. So Fast API, the library and the application base extend the Starlet framework with basically features for building APIs. These include data validation features, serialization, and documentation goodies. We'll go into a little bit of these in detail. So that's the ASGI, and this is why the sort of Fast API is built on Starlet. The descendant classes, call this superclass, etc. Yeah, and so this ASGI application, to respond, it's the app. It's treated both as an object and as a function. So it implements this call to implement that ASGI interface. And so here's the Fast API call. And as you can see, it's taking in that scope, that receive, and that send. Here now they're typed arguments. Oops. And for the most part, all it's doing is awaiting the superclass. It sets up a little bit of environment here, but it is a light entry around Starlet's router. And so we can dig into the Starlet, and we can sort of see what's happening in here. When you call a Starlet application, basically it walks through the middleware stack. Yeah, and there's a link to that code. To see how that middleware stack is set up, it's set up in the ASGI in the in the Starlet apps, basically class instantiator. So it's this build middleware stack function. It starts with the router. We'll talk a little more about the router later on. And then it goes through the middleware that's been configured in reverse order and just sort of wraps up the app call. And so this is how you build that ASGI app. Yeah. Talk a little bit about that ASGI middleware. It's possible to have ASGI middleware. So that's code that takes the role of both server and application, taking in a scope and the send receive awaitable calls, potentially modifying them, and then calling the inner application. This is from the ASGI specs. Starlet ships with a bunch of middleware by default. Basically, these are classes for adding behavior that is applied across the application. These are implemented as standard ASGI middleware classes and can be applied, either using the Starlet app or any other ASGI application that meets that interface. All right, so that's the middleware. And what you can see, the thing that the middleware is wrapping is the router. The router, Starlet would configure its own fast API, configures, a fast API version of the router. So in its constructor, you see self.router is a routing.api router, where you just feed it the routes that have been configured for the application. And so this is where that code is set up. So API router is this fast API thing, which is, again, essentially just a nice wrap around the Starlet one with some API functionality. We can dig into the Starlet router to sort of see what's going on in here. It's, again, pretty straightforward. It is an ASGI app, right? So at its core, it's got a call, takes in a scope, receive, a send, and it's just going to walk through that list of routes it was constructed with, and it's going to see if any of them match. And if it matches in full, it's going to update its scope, and it's going to sort of hand off the call to the router. Yeah, this is a very high-level description of what's going on. Here's a sort of quick class diagram I wrote. We've got that Starlet router and then the fast API router. And we don't actually use this directly in Galaxy. We use an inferring router from the fast API utils package. And so there's some descriptions on like the differences here. If you look at it, and it's pretty subtle, but it has to do with like typing and responses. It's just a slightly higher level, more usable version of the router that works a little better for Galaxy. And then we'll see later on, but we actually wrap it in another router so that we can take in some sort of Galaxy specific domain arguments. Is this route an admin route, for instance? So in order to see how we're using the Galaxy router and stuff, let's step back from this sort of complicated mess and look at how we're setting up Galaxy's fast API application, that ASGI endpoint that we're talking about. Let's look at how it's constructed. So it's constructed. So now we're like, we've stepped back from the framework code and we're sort of seeing how we set up the framework inside of Galaxy. So we sort of do some pre-set up stuff in Galaxy Lib, Galaxy Web Apps, Galaxy Fast Factory that we then use to build that fast API function. And it's pretty straightforward code here. We sort of set up the, we sort of configure the properties that we're going to read from the web server. Where's the Galaxy configuration file, for instance? Pass that to a resolver, and we sort of build Galaxy's configuration object. So this is everything in galaxy.yaml, all validated and nice using our config management code. So we build this config object, and then we get this basically WSGI app pair from it. So this gives back Galaxy's universe application function, which is a big global God object thing that we'll talk about, and then an old school WSGI app, which we'll talk about also. But then this initialize fast app function sort of takes these two and builds that fast API application. And so that initialize fast app function is in libgalaxy web apps galaxy fast app. And it's really just calling fast API. We'll come back to a couple of these, what this docs URL thing is, and we'll come back to that. We add some of our own middleware and special exception handling that's sort of specific to Galaxy. And then we walk through and we grab all the routers from all the controllers in Galaxy, and we sort of attach them to the app. And then we do some fallback to WSGI for things that haven't been adapted to ASGI yet. And we'll talk a little bit more about that. But this default fallback thing will sort of mount at the root. And then we return the app. And this is the fast API application. This is what is a Galaxy, essentially, when you're running it under UVcorn, Unicorn, etc. So there was that interesting line there right here, include all package routers. So basically this include all package routers comes from libgalaxy web app space API. And it basically walks through all of Galaxy's controller modules. And for each of them, it grabs the module. And if that module has a global variable named router, it's going to do app.include router, and it's going to include that router. So this is taking that fast app object and it's just sort of attaching on the router to that routing list, essentially. So that's how the framework looks from the routing side. But then what does that look like to like a Galaxy controller? And here's an example. We've got that router there. This is for the tags controller. So this piece of code here is basically saying we're going to use a class instead of just functions. It's just a nice little convenience function to turn a class into sort of a function that's sort of capable of being routed. But then we use this router and we sort of say router.put. And then what we put here, is the route API/tags. And then some information that's sort of used for generating the docs automatically. And then, yeah. And so this is how we set up a put to do an update using this controller code. We'll talk a little bit more about the functions or the arguments to the controller and stuff. But it's pretty straightforward. There's a lot of examples in the code. Yeah. And so that's where that Galaxy router comes in. It's got things like router.cbv, that's functionality we added. It can sort of, again, it can say admin function, this route requires you to be a Galaxy admin, that sort of thing. Yeah. So that takes care of those routes and sort of where all that stuff is glued together. But we also have this other line from that initialized fast app code. WSGI handler is WSGI middleware with the Galaxy, basically the old school WSGI app, and then mounting that. And so what does this do? This effectively provides a fallback to our legacy WSGI application. So currently, as I'm talking, it's June of 2021, and we have a bunch of controllers that we've ported over to ASGI, but we also have a bunch of controllers that are still WSGI controllers. And so what we do in this code is basically say, well, we are going to set up all the ASGI controllers, and then for everything else, we're still going to create our WSGI application, and we're still going to route using all of that. And so the ASGI middleware called WSGI middleware takes care of that sort of legacy handling. So to sort of describe what we can do from here, we're going to have to walk back through some older slides that describe WSGI. And the old school way of doing that. Hopefully next year or the year after that, when I'm redoing this talk, this won't matter anymore. But for now, huge swaths of Galaxy are still WSGI controllers. Tools, workflows, etc. We've only basically migrated the simple controllers so far. And not only that, as of 2105, we still have duplicated WSGI controllers for all of our ASGI controllers because we still support UWSGI and paste and the older Python applications for basically the older Python server applications. A lot of this ASGI stuff is future facing and a hope more than a sort of current set of things. If you go to usegalaxy.org today, you're hitting a WSGI server, and those ASGI controllers aren't actually used. But so let's talk a little bit about WSGI. It is that older interface for defining sort of web servers in Python, pre-async, right? So synchronous web servers in Python. In Galaxy, we tended to favor WSGI. Other options were available, have been available at different times. Yeah, and there are some examples and docs to them: Unicorn, Paste, and UWSGI being three big ones. We had this older school version of this What Happens in Galaxy app. It's a lot simpler because we didn't have a framework. We sort of rolled our own framework for this, and you still hit the old framework code if you're using that legacy middleware. So you get a TCP/IP request, you get a WSGI environment that runs through the WSGI middleware, and then you get to the Galaxy backend, which is the web application piece goes to a WSGI controller and then to a manager. And here, the web application in Galaxy takes the WSGI environment and it converts it to something called the Galaxy Web Transaction, and then the payload of what was in the request. But everything below the controller is the same between UWSGI, or between ASGI and WSGI. Yeah. But then, in this older code, we weren't using Pydantic and stuff, and so we got a lot of just returning JSON. And, middleware and stuff was responsible for taking Python objects, Python dictionaries, and converting them to streams of bytes. WSGI middleware, I'm going to skip these couple things. Yeah, let's just not talk about WSGI middleware at this time. The slides are there. If you have questions, let us know. Because I'm not sure the WSGI middleware is even used when you use the ASGI middleware. So it's good stuff to know, but it's sort of legacy stuff. So I guess it's not good stuff to know anymore. We have this web application thing here that I had mentioned. And so what is that? It's basically our variant of that fast API thing, right? It's the application itself. It's the thing that responds to web requests. In our case, it builds the transaction and it sort of interacts with the Galaxy's application. So we've got this app object, which is a universe application. App is still used in the ASGI version of things, and it's still this big God object that you attach a bunch of different Galaxy components to. And so we'll dig a lot more into this in the next video. But sort of to get things done, the web app, it has a list of not a list, it has two dictionaries of controllers. Older controllers that return HTML, and then slightly newer controllers that return JSON things. And so these are called controllers and API controllers. It's got a routes mapper, and so this is how we were doing routes before Fast API's variant of it. And then that handle request function gives an environment start response. That's the WSGI interface point. And then we've got this transaction factory, which produces this transaction object, which is sort of a description. If app is a description of all of Galaxy's components, trans is a description of the whole current request. It's what route was hit, who the current user is, what their history is, etc. So both of these are very heavy objects, but sort of very important to older style Galaxy controllers. And I say older style Galaxy controllers, but they still represent a majority of Galaxy controller code. Yeah, and so we've got a little web framework here that we sort of built up over the years. So we've got like a base web application, and we added Galaxy specific stuff, and then the Galaxy's concept of web applications, and then the actual Galaxy app application. And then same thing with that transaction. So you can sort of see there were layers here of like a framework, and then how Galaxy would use the framework and how Galaxy does use the framework, if that makes some sense. yeah, hopefully this is all legacy. A year from now, we can delete the slide. Um, so routes looked a lot the same, except for instead of the route being defined on the app, the route was placed in Galaxy Web Apps Galaxy Build app. So the routes was a little bit more centralized before. But the idea was still, here's a URL, and there are parts of the URL that you parse out. Um, and it works a lot the same that Fast API does, to be frank, in terms of like pulling out pieces of the route and turning it into parameter arguments. I mean, most web frameworks do the same thing, even in other languages, right? This is Ruby Rails 101, for instance. So if I hit the URL datasets this ID display, then I'm going to find a function, on the controller dataset called display, and for dataset ID, I'm going to be passed this thing. And we use some library code for this called routes. So the core of our sort of handle request was here. What we would do is we'd look at the path, we'd use a mapper to map, and this is using that routes library, figure out which set of controllers we're going to use to find the corresponding functions to call, build a transaction object, grab the controller name, use whichever set of controllers we're using, find that method name, build the function, build the calls to call the function and just call it. And so this code used to be in Galaxy, now it's in Fast API for ASGI. Okay, so we've got three different varieties of controllers that we've talked about now. We've got the Fast API ASGI API controllers, we've got the WSGI API controllers, and we've got the legacy WSGI web controllers. Ideally, each of these is very thin. So while, the specifics of how they're called has changed, I think the design of what they should look like inside is largely the same. They should all be thin because they're all tying us to specific frameworks. So they should be focused on web things, adapting parameters and responses to Python objects, because hopefully pedantic for most things now, and then move the business logic and components not bound to web functionality, right? So the controller should do little lightweight things and then move off to other components, most of those components being managers. But I will talk a little bit about each of these three controllers. The Fast API controllers are in this directory, lib Galaxy Web Apps Galaxy Controllers API. They consume and produce typed data using Python 3 type annotations, Fast API helpers, and pedantic models. So they're really nice to work with. More documentation is expected, but it lands up in a nice interface. The router specifies an HTTP verb, get, post, put, etc. On how to parse the path. That happens right in this file instead of in that build app file. And so here's an example. In API roles, we've got this role manager, this role controller that has a get at API roles, has a get with an ID parameter, and that ID comes here, it's typed, it's an encoded database ID. And look at, even this code is using trans, right? So that transaction is something we're still using, even though we're trying to get away from it. Fast API gives us a lot of ability to get away from doing that, but we haven't made full use of it yet. So you still see code like this where we're taking in that transaction. And then here's an example of a post. And this is an example of the router using Galaxy specific stuff, require admin. So we'll get very specific exception handling for non-admin users that matches the old WSGI controller code, etc. All of that magic is taken care of at the framework level, the Galaxy setting up the application. So if you're writing a controller, you don't really need to care about any of that stuff. You're dealing with these pedantic models. And in each of these cases, these methods are not more than a couple lines. That's ideal. We're just sort of, parsing the requirement, parsing the parameters to the function, and then handing it off to the role manager to do all the work, and then adapting the Python results to sort of the web request. So in this case, for instance, converting it to a Pydantic model that FastAPI knows how to serialize. So we'll talk a little bit about FastAPI and Pydantic here. Pydantic is basically a model builder. It sort of takes Python objects or Python classes with type annotations, and it knows how to convert them to JSON. It's relatively straightforward. In this role case, we've got a couple different field types with some documentation that all ends up in the API docs now. So we've got a basic role model, which extends Pydantic's base model. And it's got an ID, which is type this role ID field. So when we're building API docs, we know, the title and description to use for those things. The name is the name of the role. It's a string. Name type. And then the role model, has a couple more detailed things. So when you're like really digging in and you've got you're showing an individual role instead of like a list of roles, there's more information. And then the role definition model is got some more stuff. So when you're creating the role, you can use user IDs, group IDs to sort of create the role with some extra information, setting it up properly. And all of these types are sort of automatically inferred and validated. So that's great. All of that code comes through that now we have nice open API documentation from all of those type signatures and all the field descriptions and stuff. So it's a modern API. Traditionally for the API documentation for Galaxy, we would tell people to go look at BioBlend. But now we've got the nice sort of industry standard open API docs that we're getting for free from our controllers. Not for free, but by annotating the controllers properly, by doing things in a type safe way, in a high level way with Pydantic, we're also getting these nice documentation. And so back when we set up our FastAPI controller, we set up API docs as the docs URL. So now when I start Galaxy and UVcorn, if I go to Galaxy's root /API/docs, this is what I see. I can sort of, here are those API roles. We can sort of see how that ID translates here. And we can see the two gets and the post. And we can try it out also. So that's the FastAPI controllers. We've got those slightly older school WSGI API controllers. They're in the same directory. So they live side by side because they're being duplicated currently. We've done a lot of work to make it so that the older style controllers can still return Pydantic models, for instance. They have dependency injection for setting up their dependencies the same way. So we're trying to make it as easy as possible to sort of have very thin controllers that work for ASGI or WSGI. And we put them all in the same place. They're mirrored. Hopefully with 2109, if not that, the next version after that, we eliminate WSGI as a possibility in Galaxy and sort of we can depend on ASGI and FastAPI. These controllers all take in trans and request parameters, right? So it doesn't have that nice request parsing using Pydantic. That's something you've got to do inside the controller. But it's pretty easy to do. Pydantic makes it really, really nice and easy. And if you're setting up those Pydantic models for the ASGI controllers anyway, it's relatively straightforward to just build them from the Galaxy request. Here's the same role API controller in the slightly older fashion. This is the same piece of code. So we're setting up our role manager the same way. We'll talk about this in a little bit. And we still have three methods. Here we were using, to sort of specify something as requires admin in the older style, we've got an annotation. We've got a decorator, basically, and not an annotation. We annotate it via decorator. And we also annotate each of the API methods as, with this decorator. We've got all this documentation here in the doc strings. This was sort of not functional, right? Like this is not like functional documentation. It's stuff that would appear, I guess, in the PyDocs, but it wasn't useful and actionable in the way that OpenAPI is. So it's this is the best we could do at the time. But yeah, it's clearly inferior. It makes the code more verbose and you get less out of it. But the actual inside of the function, it's largely the same. The difference, we can still return the same things. We're still returning Pydantic models, and Expose API knows what to do with that. The slight difference here is that we have to sort of do some work to set up our inputs. We adapt the payload to Pydantic before we sort of send those Pydantic models off to the role manager. And then finally, we've got the legacy WSGI controllers. These things produce HTML for the most part, or arbitrary content. They're in a different location. We're attempting to minimize them. They're not ideal. To do HTML rendering, it's mostly done using Mako templates. And these templates are in the templates directory. Mako is something, again, that we're trying to get rid of. There's still a lot in templates, but the number of templates, the number of these controllers is going down over time. We should be using, all new features should be leveraging API calls and really shouldn't be like designing web applications this way. And that's sort of the anatomy of our request, everything from what the top level server is doing to how the frameworks work to what the controllers are, how things are parsed. There's a million things there, but that's what I've got for now. Thanks so much.